Dear teachers and students, my name is Pengpeng. I am a student from Dalian Polytechnic University. At present, my research direction is image enhancement in bad weather environment. It's my great honor to report my recent research work on Chinatown. The title of my paper is MCAD-Net Multiscalar Coordinate Attention Dense Network for Single Image Deraining. I will mainly report from 4 chapters. First, I will introduce my research direction. Secondly, the second and third parts are the network architectures and the experimental process I proposed in the paper. Finally, it is the conclusion. Okay, then let's first look at some factors that can cause image degradation. From the time of obtaining data, the factors are mainly divided into 3 categories: before data acquisition, now after data acquisition. The factors, for example, underwater, no light, motion blur, watermark. My research direction mainly about image enhancement in bad weather environment such as heavy rain, snow, mist. These are some common bad weather environment image: raindrop, rain streak, mist, snow. In this paper, the Deraining model I used is shown in PowerPoint. Y, YC, YR. Y is rain image. YC is the touched image, unnamed clean image. YR is the rain streak image. A raining image can be viewed as the superposition of a clean background image and a rain streak image. At present, the related work in this research direction mainly includes 2 categories. One is based on a prior method, for example, specialty theory. The other is based on deep learning method, for example, the CNN. The method based on a prior mainly include specialty prior, no rank prior. The specialty prior learn 2 different dictionaries to specially represent clean image and rain streak components separately. The low rank prior is leverage patch rank as superior to characterize unpredictable rain streak patterns. Recently, in the field of image, the method based on deep learning has been widely used. Single image rain removal based on deep learning started in 2017. Yang constructed a joint rain detection and removal network to focus on the removal of overlapping rain streaks on the heavy rain. We set the low quality image as the input and get the high quality image through a data-driven solution. These are some image deraining examples from rain image to clean image. Although the methods mentioned above have achieved good results in many application scenarios, there are still many limitations. By observing the image, we found that the pedestrian's arm and the player's nose were lost due to image restoration. Because image rain removal is a complex process, most rain removal models based on filtering and purity methods are not enough to cover some important factors in real rainfall images, such as rain streaks, as for the method based on deep learning. It ignores the internal mechanisms of rain, making it easy to fall into the process of over-adapting train. Many exciting algorithms are limited to some image blocks or limited perspective, and can't obtain image feature connections between large regions, resulting in usually unable to restore structure and details. But it's kind of information that is ignored due to the limited perspective field has been proved to be very helpful to the image to remove the rain. Okay, to address the above-mentioned issues, the paper presents a multi-scalar coordinate attention density network called MCAD-Net. The proposed MCAD-Net is based on DensNet. The DensNet has several compelling advantages. They alleviate the vanishing gradient problem, strengthen feature propagation, encourage feature reuse, and substantially reduce the number of parameters. Multiscalar coordinate attention block (MCAB) is introduced to better unifies multiscalar information and feature attention for improving the rain feature representation capability. Combine the features of different scalars and layers. Multiscalar manner is an efficient way to capture various rain streaks. Commoners, especially in the heavy rain conditions. Recent studies on single image deraining network design have demonstrated the remarkable effectiveness of channel attention. For example, the squeeze and the excitation attention for lifting model performance, but they generally neglect the position information, which is important for generating spatially selective attention maps. Therefore, coordinate attention model is involved in MCAB. In this way, long-range dependencies can be captured along one spatial direction, and meanwhile, process positional information can be preserved along the other spatial direction. The coordinate attention model helps the proposed network to adjust the three color channels respectively and identify the running region properly. We evaluated the proposed network on the public, competitive, benchmark, synthetic, and real-world dataset, and the results significantly outperform the current outstanding methods on most of the deraining tasks. This is coordinate attention block. The overall architecture of our proposed coordinate attention block for image deraining. Compared with the original coordinate attention, an adaptation model is added. The goal of coordinate attention block is to capture cross-channel information, while also capturing direction, perception and position sensitive information, which helps our network model to more accurately locate and identify more important objects. This is multi-scale coordinate attention block. Architecture of our proposed multi-scale coordinate attention block MCAB. It is mainly composed of a multi-scale feature acquisition model and a coordinate attention model. This architecture enables the network to better explore and recognize features in different. In this model, we set the input to F in. We can get F out, as shown in the picture. In addition, we also innovate the loss function. This is contrary to the human visual systems. So, the correlation between MSE as a loss function and the image quality is proved. In order to solve the above shortcoming, we combine MSE and SSIM to propose a loss function, so as to achieve a balance between the effect of image ring removal and the image quality evolution. The next, I will introduce some about the experiments. The first are the experiment tools. The number of MCAB in MCAD-Net is set to 6. The reason will be explained ablation experiment. For all the datasets, we redeem crop 6464 picture from each input image. The training workstation is configured as Ubuntu, memory 16, emitter P102 GPU. During training, the batch size is set to 32 and use a DAM optimizer to train a total of 100 approaches. The initial learning rate is set to 1, and the learning rate is reduced by half every 25 approaches. Four static datasets and 2 real-world datasets will be used to evaluate the performance of proposed methods. The composition of the datasets is shown in Table 1. For example, the Ring 100L. It is have 200 train sets and 100 testing sites. This picture is about visual quality comparisons of all computing methods on static data set, Ring 100H. This picture is visual quality comparisons of all computing methods on static data set, Ring 100L. This is about results on real-world datasets. It can be found that the proposed method has better ring removal effect and detail retention. The performance of image ring removal methods is usually evaluated according to peak signal to noise (PSNR) and structure similarity (SSRM). The higher the PSNR, the better the performance of restoring ringless images from ring images. SSRM value represents the similarity between two different images, and the value range is 0 to 1. When SSI is close to 1, the ring removal performance is good. The quantitative results in the table are evaluated based on the PSNR and SSI, average results of the static dynamic data size, and the best results are shown below. Then let me introduce the ablation study. In order to study influence of different numbers of MCAB in MCAD-Net on network image ring removal, experiments are conducted with RAN 100L as the reference data size, where the number of MCAB ranges from 2 to 10, and the experimental results are shown in Table 3. It can be seen from Table 3 that is in the ablation experiments of multi-scalar coordinated attention block numbers, the PSNR and SSI values can be improved as the number of MCAB is increased when n to 6. The evaluation value reaches the highest seat, and then it begins to decline. Therefore, considering the balance between efficiency and efficiency, we set the number of MCAB in the proposed network to 6 by default. Ablation study on coordinated attention models. The coordinated attention model is introduced in MCAB. In order to further verify the efficiency of a coordinated attention model, the basic multi-scalar function network compared with the improved network with the attention model, as shown in Table 4. The coordinated attention model can bring improvements in PSNR and SSI. Ablation study on loss function. We use the quantitative combination of the MCAE and SSIM loss functions. The total loss function has achieved better result. The last is conclusion. In this paper, a multi-scalar coordinate attention depth network is proposed to remove RAN from a single image. MCAD-Net is based on DesNet and uses the multi-scale connections to achieve feature results and for dissemination of future information. In order to better identify and characterize the future information and ring streaks, multi-scalar feature acquisition and coordinated attention model are introduced to form a multi-scalar coordinated attention block. First, get ring streaks features of different scalars through convolution kernels of different size and fuse them. Then, the attention model is used to further explore the ring streaks features in different channels and space. The retentionality of model introduction and parameter setting is proved by ablation experiments. Finally, the proposed method is tested on the common static data size and real data size, and compared with the latest advanced method. Both showed better performance. In addition, the method proposed in this paper also better restores the details of the ringless image. In the future, we plan to extend our research work into radio deraining on the autonomous driving. For example, adding a additional model to our network to capture time information. Thanks for your listening. Welcome to communicate with us.